All right, this is chapter 19 of PS100, and we'll be doing about a 5-minute review of this chapter. So this is really all about equations and about the basics of molecules. So we'll start first. Here's the basics of an equation. We have the reactants here, Mg and F2, and then throughout their reaction, they'll go to MgF2, which is the products. Now, a mistake some students make is, okay, what do these actually look like? So in this half of the reaction, it'll be one lone Mg atom, or maybe 100 of them, or 1,000, and then there'll be a molecule of F2, and they'll be bonded together. And then when these two molecules interact, they'll go to MgF2. And then you'll notice here that it's also balanced. So there's one Mg on this side, and then there's one Mg on this side. There's two Fs on this side, and there's two Fs on this side. So that's the basics of the equations. Now we'll go to balancing equations here. This is a little bit more difficult, but we'll learn how to balance this equation. So you notice here, there's 3 C's, and then there's only 1 C on this side. So the process of doing this is you're just going to count how many molecules are on each side. So right here, we have 3 right now. We have 8 H's, and then we have 2 O2s. And then on this side, we have 2 H's. We have 1, 2, 3 O's, and then we have only 1 C. So we know we need to increase the C's and the H's, and then on this side we need to increase the O's. So I'm just going to try out a number and see if it works. So I'm just going to say, okay, let's just put this to 3 here maybe, because I know I need 3 C's. So that makes 3. That makes 6 oxygen, plus 1 is 7. Now it still doesn't match, so I'm going to do another number. So I'm going to maybe increase H2O to make this an even so that potentially this could match. So I'm going to put a 4 here, and that makes 8 H's right here, and then that makes 4 plus 6, so that makes 10 O's. Now we'll see if we can balance it on this side. So C's, we're good on C's. Now we need the H's match, and then we just need to double or to times the oxygens by 5. So I'm going to put a 5 here. Now the great thing is that you don't have to balance equations yourself. You just need to identify which ones are balanced and which ones are not. So if this were a 4, then you'd count all these up and realize that it's not balanced. So you'd say that's incorrect. But now that you know the process of balancing equations, you'll be able to identify real easily. All right, that's balancing equations. Now we have this mass spectroscopy and this vibrational spectroscopy. So what these are basically scientists want to figure out what certain molecules are and what they're made of. And the way they do this is they use this mass spectrometer, and they put basically this molecule in a machine, and they break it up. They put it through a film or whatever, and they break it up into its normal pieces. It's like putting Oreos in a bag, shaking it up for a while, and then seeing what pieces you have left over. So right here, that's representing, okay, here's some pieces, and here's a film to detect that. And then they get this graph, and this graph is what you need to know about mass spectrometry. So you need to see that this molecule creates particles of these masses. And depending on how high the line is, that tells you how often that particle exists when this molecule is broken up. So what you'll have to do is you'll be given a molecule of some, so say they give us a C3H8, and then you go to the periodic table and you count up the mass of C's and H's. So here I represent C's in black and H's in white. And so when you count up the masses of 1 C is 12 times 4, and then masses of H, or hydrogen, is 1. And so the total is 58. Then you'll go to a list of 3 or 4 graphs, and you'll have to identify which one matches this molecule. And the way you'll tell that is by the last line. So if you break up a particle, there's no way that this particle, this molecule will make a particle with a mass of 70. So you'll be able to get rid of all those graphs and come up with this one that does have a line at about 58. Okay, that's mass spectroscopy. Another way that they figure out molecules is by vibrational spectroscopy. So the background of this is that molecules, because of their bonds, they'll shift a little bit. So say we have Mg and F, like we used before. F's maybe will shift up and down, or to the left or to the right, so they'll always be vibrating. And then they'll give off wavelengths of infrared light. That's also why we call it infrared spectroscopy. So what you need to see is this graph showing the absorptions of these different wavelengths. So this molecule had these wavelengths emitted from it. And then you'll have to see, does this match one of these? And if they do, then those molecules are in similar families, or those molecules look similar, they have similar bonds. So you'll see here, there's a wide wavelength here, there's a double right here, and then there's a long dip. This one, as you see, does not match because this is not as wide, this is not quite a double, and then there's the big problem here is that there's this double instead of a single dip. And so you'll see that this matches this, and so that those would be similar molecules. Okay, that's chapter 19.